Assalamualaikum warahmatullahi wabarakatuh. Today's topic is about radiative heat transfer. So basically, this subchapter will I will explain about the view factor. So since the view factor have 4 different rules, therefore I will divide this subchapter into 4 different videos, where each of the videos will explain a different types of rules for the view factors. This is because to make you understand more on each of that rules before you go for the example, and you can actually calculate whatever the problems or the question asks you to find. Okay, so the objective of this subchapter, is when you finish studying this chapter, you should be able to, one, define view factor and understand its importance in radiation heat transfer calculation. Second, develop view factor relations and calculate the unknown view factors in an enclosure by using these relations. And the last one, calculate radiation heat transfer between black surfaces. So radiation heat transfer between surfaces depends on the orientation of the surfaces relative to each other, as well as their radiation properties and temperatures. So we know, take a look at this figure. We have 1 point sources and 3 different surfaces. Okay, surface 1, surface 2, and surface 3. So these point sources will radiate energy or emit energy. So when it emits energy, it will strike surface 1, surface 2, and surface 3. So therefore, how to calculate the rate of radiation, the rate of heat transfer by radiations? We will use view factors as one of the components inside the Q, and after that we will calculate the rate of heat transfer for the radiation. So what is view factor? View factor is defined to account for the effects of orientation on radiation heat transfer between 2 surfaces. View factors is purely geometric quantity and is independent of the surface properties and temperature. So diffuse view factors, we know that diffuse is independent of direction. The emissions of that radiation is the independence of independence of the directions. Therefore, view factor based on the assumption that the surfaces are diffuse emitter and diffuse reflectors. So which means whatever surfaces roughness it is, it will depends on that. It is not independent. It is independence of that directions, which means that every materials have different kinds of emissivity, right? And specular view factors based on the assumption that the surfaces are specular reflectors. And for the view factors, it is simply means diffuse view factors. What is more important in this video, in this subchapter, is about on how you will calculate the view factors itself. So based on the rules itself. So you have to understand about the rules before you can calculate the rate of heat transfer by using these view factors. So it is important for you to understand about the rules before you go for the rate of heat transfer. So now this the form of view factors here is Fi. Sorry. So the form is Fi to J, which means that if you have 2 different surfaces, let's say this is surface 1, and then you have another surface here too. So what if the value of F view factors from surface 1 to surface 2, which means what is the view factors of this? Okay, from 1 is the base or the source of that radiation. We want to find what is the view factors from 1 to 2. For example, J is the second surfaces. Okay. So Fi to I, if J here is the I, so which means if 1 to 1, which means that 1 strikes 1 back. Okay, radiation leaving surface 1 that strikes itself directly. So there are 3 different surfaces here. First is plane surface, B is convex surface, and C is concave surface. So plane surface here, if we can see, this is surface 1. Okay, take a look at only this surface. Okay, 1. So if 1, I is 1 from 1, this surface 1, and it strikes to 1 back. So at this point, if F1 to 1 for the plane surface, it will equal to 0, which means that I always give example to the students, illustration to the student. It's just like a mirror, where in that mirror you have a picture, or maybe you are in that mirror. So let's say here, this is mirror, and then you are in here. Okay, oops, sorry, saying hi. And when you are saying hi, do you see an image of yourself strikes to you? Which means, do you see any reflections of your image? Of course no, because there is no mirror here. There is no other mirror here. Therefore, if you cannot see what you do, let's say you lambai-lambai dekat sini, so say bye-bye, and then you cannot see what is your whatever you do in that mirror, therefore you will equal that to 0, which means you cannot see whatever you do from the other mirror. Okay, that is the plane surfaces. Okay, you cannot see whatever you do to yourself. Okay, for the second one, convex surface. So let's say this is point 2 and you are in the convex mirror. So for example, you are in the convex mirror, and then you try to lambai-lambai here, waving in the mirror, and then what will happen? You will not see whatever you do in that mirror. Okay, am I right? If you can see whatever you do, then you have some special ability, maybe mutant. You can register with Professor X for that reason. So in that mirror, you do whatever you want and you cannot see whatever you do. You know what I mean? So which means that if you calculate the view factor F from the point 2 is the source, so the I is 2, and then you cannot see whatever you do. So does it strikes back to you? No. Therefore, if no, then you cannot equal to 1, but you will equal to 0. Okay, that is convex surface. Convex and plane surfaces is the same. It will equal to 0. Take a look at concave surface. So you are in a concave mirror. Okay, concave mirror, and you done something in the mirror, maybe waving and saying hi, bye here in that mirror. Then you will strike, that image will or the radiation, the energy will radiate or emit, and some of the energy will strike to the other surfaces and will strikes it back. Do you get what I mean? So let's say this is the radiation, it will radiate, emits energy, and then terkena dekat sini. Okay, let's say, and it will strike back to the surface, surface 3. At this point, F3 to 3 not equal to 0. So you have to calculate what is the value of that F3 to 3. Okay, and to understand and to know how to calculate the F3 to 3, and after this you will know about the rules, And that rule is actually will explain to you and teach you on how to calculate the F3 to 3 for different cases. Okay, so at this point, F3 to 3, 3 is the surface. This surface will emit or radiate energy, and then does it strikes back to point number 3? Yes, but maybe there is some value, not necessarily equal to 1, and then it will have values there. And the values of F is 0 to 1. Either is 0.5, maybe some of that. Maybe you will radiate 1, for example 1, and then it will strikes back to you about 0.5. And that is that value 0.5, F, that value must be determined by using the rules. Okay, so at this point for the concave surface, we cannot say that F3 to 3 is equal to 0. So as I mentioned before, if you are in that mirror, concave mirror, and you waving somebody, and you will see your image here, and that whatever image that you see maybe is only half of your body here, one body here you waving, and then you will only see half of your body here, because this will radiate energy and some of it will strikes back. When you see your image, it means that it will strikes back to yourself. Okay, that is what I mean from plane surface, convex surface, and concave surface. So please remember that if you are dealing in that problems or in that questions, plane surface, convex surface, that F1 to 1, for example number 1, F1 to 1 must be equal to 0, whereas the same as convex surface, F2 to 2 is equal to 0. So for a concave surface, it is not equal to 0. Maybe some of there is a value here. Okay, but there is two values, 0 to 1, and what view factors that will equal to 1? F1 to 1 will be equal to 1 when it is completely surround the surface. So for example here, this is inner sphere and that is outer sphere here. It is completely surround the inner sphere. When it completely surround its inner, so let's say you are here waving somebody, which means you are waving, and then this mirror you will see the whole of your body here. You will see, when you see the whole of your body, which means that that image will strike back to you, which means if that energy radiates from here, radiates the energy, and it will go to here, and after it goes to here, it will reflect back and strikes back to yourself, to this surface. So, and when it is completely surround, and which means that when whatever amount of radiation that been radiates, it will strikes back to yourself. Okay, it will strikes back to surface number 1, and for that condition, it will be equal to 1. So F, for example here, where is the point? So for example here, F1 to 1 is equal to 1. Okay, F1 to 1 is equal to 1. What will happen to F2 to 1? F2 to 2? No, F2 to 2 is not equal to 1. Okay, it will not equal to 0. Okay, F2 to 2. F1 to 1 is equal to 1. F2 to 2 is not equal to 1. Okay, so there is 4 tables actually that you will refer in order for you to calculate the view factors. So table 13.1, and this table have different geometries. So for example, if you want to find the surface, these two surfaces, I is the source, for example 1 to 2, for example, your geometries of your question is in rectangular, and then you want to find the base y-axis, this area to this area, okay, you will use this kinds of relation in order to find what is fi to j, okay. And you don't have to worry, I will teach you in the example on how to use all these tables. And then coaxial parallel days, if you have encountered in the problems or in your questions the geometries like this, you will use this relation and so on. So this is another geometries here, so you may use if you encounter with all of these geometries. And then this is the next graph. So this is 2 tables, sorry, I mentioned about 4 tables. You will refer to these 2 tables and then these 2 graphs. So if you don't want to find, for let's say, let's take a look at here. So this geometry is actually the same as this geometry. So if you don't want to find your relation in here, you may use these kinds of information. But it is important for you to find the ratio L1 over D. So you will see this figure on the top of this graph. So please L1, substitute the values based on this geometry. So do not simply assume that L1 is here or L1 is here, okay. Please refer to this figure and make it tally with your examples. So you have to find what is L1 over D and then ratio L2 over D, and then you will try to let's say you find L2 over D, for example 2, and then you draw a straight line upward, and then for the L1 over D, and for the value is 10. So you take a look at the point of interception and then you drag and find what is F1 to 2, okay. So this is the surface 1, A1 to A2. If you have rectangular surfaces, rectangular shape or rectangular geometries, we have these kinds of figures here. So if A1 stretch to this side, so this is from bottom to top, so this is from bottom to side, okay, you will use this figure, this graph. Now the next is this is the first relation. It is actually the rules. So reciprocity relation, what you have to know is the reciprocity relation says that for the A1, Fi to j is equal to Aj Fj to I. So for example, if you have two different surface, so let's say here is your first surface 1, and then there is another surface here, sorry, surface 2. Assume that this is rectangular, yeah? So if you want to find this reciprocity relation, if you have the same area here, rectangular box, and we know that the rectangular have the same geometries, have the same dimension for the surface 1 and surface 2, therefore this is A1. So for surface 1, so we want to find what is F1 to 2, okay, equal to, so area to F, you want to find 2 to 1, 2 to 1. So you will cancel out the area, so you will know that F1 to 2 equal to F2 to 1. So whatever values, whatever radiation here strikes to the point 2, the point 2 will strikes back to the point 1, the same values of the view factors, okay. And at this point, when the area 1, area I, area 1 and area 2 is the same. If the area 1 and area 2 is not the same, therefore you cannot simply make the assumption or make these kinds of formula. Fi to j is equal to fj to I. So if the area is not the same, therefore you cannot simply conclude that Fi to j is equal to fj to I. So let's say you have these kinds of figures here or geometries. A very box here, a very big box. This area, this is 0.2 and this is 0.1. Both of these have different areas. Therefore, you cannot use the reciprocity relation to simplify some of the view factors. Okay, because the Fij, F1 to 2 is not equal to F2 to 1. So you have to find what is the values of the view factors for these two surfaces. Okay, and this when you encounter these kinds of forms, what you have to do, so you have to refer these, okay, these figures. Okay, so how much and how many of the view factors that you must that you have in your questions or the problems. So radiation analysis on enclosure consisting of n surfaces requires the evaluations of n square view factors. So for example, you have two surfaces here. So this is surface 2 and this is surface 1. So you have two surfaces. So 1 and 2. So your n value is 2. So to find how many view factors for your problems, evaluation of the view factors, you have to calculate 2 to the power of 2. So how much that you get? You will have 4 view factors. Okay, 4 view factors. Do we have to find all those 4 view factors? No, not necessarily. Maybe you have to find all those 4 view factors, or maybe you may use fundamental relations for view factors. Sorry, because I've already explained about reciprocity relation before go to this slide. The first fundamental relation is the reciprocity relation. Okay, let's say for this I explained before, the reciprocity relation, you have surface 1 to 2. So you have actually 4 view factors. Okay, you have 4 view factors. Therefore, you can actually reduce these view factors, and after this, in the summation rules, okay, you will understand how many of the view factors is actually needs to be determined or need to be calculated. Okay, and for the reciprocity for relation, for example, from 4 we can actually reduce up to 2, because you will calculate F1 to 1, F1 to 2. Okay, for this, okay, I refer to this figure. So you will try to find F1 to 1. Okay, that is the first view factor, and the second view factor is F1 to 2. And then F1 already finished, right? F1 to 1, F1 to 2. So now we go to the next surface. So F2 to 2 and F2 to 1. Okay, so we know that F1 to 1 equal to n F1 F2 to 2 is convex, is plane surface, right? So this is equal to 0. So you can reduce these two. From the first one here, this kind of surfaces, we are dealing with plane surfaces. So when you are dealing with the plane surfaces, we know that f1 to 1 is equal to 0. Not necessarily f1 to 1, since in this figure we are denoting these surfaces as 1. Therefore, this will be f1 to 1. If you denote these surfaces as 2, then it will change the notation of the subscript f2 to 2. So now here we have 2 and 1, therefore f1 to 1 and f1 to 2, f2 to 1 and f2 to 2. So now f1 to 1 and f2 to 2 is equal to 0 because it is a plane surfaces. So we reduce that 4 surfaces, 4 view factors this. Now we have 2. So now we use reciprocity relation. Do we have the same area for the 1 and 2? Yes. Therefore, you may reduce one more because you have to calculate 1 to 2. So from 4 view factors, you reduce up to only one view factors only. One view factors only to be calculated from 4 numbers of view factors. Okay, you may reduce by using by the aid of the summation rule, superposition rule, and symmetry rule. You are actually can reduce your number of view factors. From here, we have we have 4 different types, 4 different view factors, and then it will reduce up to only 1. So, how to find f1 to 2? So to find f1 to 2, you may use this graph. Okay, you have to calculate L1 over D, and you have to calculate L2 over D, and then find the intersection. Then you go to calculate for f1 to 2. And then you are actually already solved for these view factors. And after this, in the example, you may know where do we need to put these view factors in our rate of heat transfer equation. Okay, that's all for the first relation, reciprocity relation. And after this, after the next video, I will teach you about the next fundamental relation for the view factors is summation rule. Okay, thank you.